Okay, board layout is done, and I went through all of that, of course, to make this happen. Of course, at the top there, I have my bad edge. I used a Dremel to cut it, and it melted things. Not really bad. I don't really care that much. Actually, I do, but I'm gonna act like I don't. So this is the paper layout transferred to the board, and yeah, I'm gonna start putting the standoffs in, and I'll get that video out to you guys. Alright, let's do it. Alright, and we're done. Took a little while. I had to bore out some more holes. Some of these measurements were off just by a little bit, like really by 0.5 millimeter, so really small, and all I had to do is just make the hole a little bit bigger using my 1/8 bit. That allowed me to get the larger hole to allow me to fix some of the problems that I had with my spacing. So I got everything mounted that I need for right now, and looks really good. I'm actually very impressed with it. Very clean. Just, I mean, there's not much on there. That's how it looks from the bottom. Yep, that's pretty much it. But yeah, so now I can wire this thing up and you know, get everything going, and then maybe even lay out some of the some clean wiring points here. For instance, most of the wires are going to be running along this side, this way. I might have them just running over the air, but I'd like to kind of like secure them down, just so we get less movement. So that's pretty much what we're doing here, or that's what I'm planning. You can see the epoxy glue in the background there. I want to glue on the PoE injector. That's a 5 volt PoE splitter injector, and I drilled the hole, even though I told myself not to drill it, but I put a mark there. But essentially that mark, or the mark that was there, which is now a hole, signifies where this is actually going to lay. So this is probably about, I think it's 14 millimeters away from the edge, and it'll sit right there, and then accept the Ethernet cable here, and then not drop once it's glued, and then split everything from there, or split the power and the Ethernet traffic. So that should be cool. As always, thanks for watching. Alright, we got our board wired up here. This took a little while, of course. Got my sensor adapters here, and then of course I can hook up my sensors later. I do still have those plugs from when I first did all of this, but it's a lot of pins, and I had to write everything out here, pretty much what equals what. So this is just a relay to GPIO. So N1, which is right here next to the ground, which is orange, connects to IO5, which is pin number 29. It's good to know what that relation is, because if we do everything the same, then when we go ahead and start programming all this, at least the physical portion of it is predictable and in the right place. So N1, IO5, number 29, so that's GPIO number 29, or another name for it. And N1 goes here. No, that's the digital one. Again, these colors are arbitrary, so it doesn't really matter. Oh, so IO number 5, which is right here on the breakout board here. So, but pretty much you go through. So N1, IO5, number 29, 2, IO6, number 31, 3, or N3, IO12, number 32, N4, IO13, number 33, N5, 19, 35, 6, 16, 36, 7, 26, 37, 8, 20, 38. Got all that wired up and hooked up there, and then I moved on to the digital sensor. With the Raspberry Pi, I can mux the ground and the the voltage, because it doesn't require much voltage for these digital sensors. In fact, I think in my other Raspberry Pi, the branch version 1.5, in that prototype I have 5 of these sensor adapters in a small water type box, or waterproof box, or water resistant really. Water resistant box, and it has 5 of them. All of them are connected to IO4, which is the only digital GPIO port or pin. So that's back here, and as you can see, I have these 2 sensors. Their data, or the D, right here, which is green on this little connector cable, which translates to another color here. Again, these colors are arbitrary. It's all copper, and we just need to, it kind of helps us when we're connecting stuff to keep track of it, as long as we do kind of one thing at a time, and that does definitely help, especially help me. So IO4, you can kind of see that there, and I have both of those pins in there. I have to test if that works properly. The other one, I have it like kind of twisted up to one another. I want to see if I could probably even put like some type of board where everything connects to the same thing. I believe I can do that with a breadboard, but I don't really like breadboards. They just kind of look messy to me. I'd rather do this screw-in terminal. It looks better to me. But I want to find some way to mux it so that I only have one connector going in here, and since it's digital, it can't be muxed. I've done that, and it works fine. The power is the same thing. So these digital IO sensors, or these digital thermal sensors, only require 3.3 volts of power, and that's fine. I believe you could put it in the 5, but I would not suggest it. But you can mux that as well. And then for their ground, for each one of these, I didn't feel, it's kind of hard to mux these. So, and I didn't want to like use up some of the grounds up here because of the way this terminal is set up with these with the cables that I've put in there. If I had just the cable stripped and then placed in there, which I do not recommend, it's not the cleanest, and I don't feel comfortable with it after using it. Previously, when I first started this, I like using these cables with these with the male connectors on them, like so. But these are male to male, and then these are female to male on this side. But get this thing into view. But with these, if I have this in place of this, I can't get to it, so I'd have to unplug this to get to that, and I didn't feel like dealing with, they were kind of close here, and it was like kind of bent or squeezed in there like that, and like I have an IO4, and I just didn't want to feel like dealing with that, so I just have each one of them into their own ground. I don't plan on putting too many sensors on these control boards. Really, that's something that I really want for the branches. These control boards are mainly just for these devices here, and that's really what I want to focus on. I only have so many though, of course, with the Raspberry Pi. I think there are ways to expand it to get more, which I'll have to look into a little bit more. I think I've seen some articles on it where you can kind of like daisy chain some of these boards. I'm not sure about that. I know with some of these, well, I know with some of these boards they're on these GPI pins, they're stackable, which is kind of nice. So the more GPIO pins I have, the better. This would be, I would run into an issue, of course, but the way I get around that, actually, if necessary, is what I could do is use an APC 92 or APC AP 9211 network PDU or smart PDU. That smart PDU allows you to control those those ports via the fence. I think it's like fence APC daemon or binary. You can download that in Ubuntu. I've used that on another project, but what's nice about it is you can actually get the information from the PDU itself, whether it's on or off, and then you could put in some logic from there. Also, you can just the only thing about it is you have to give it time to reset. So they're smart, but they're real slow in terms of I guess you'd say slow. I don't probably not the best term to use for people that get triggered, but they're smart, but not that smart. So if you query it too much, it'll actually have a timeout because it can't handle that many queries. And that's on some of the lower end smart PDUs, the ones that you have at the top of the rack that has probably about 10 amps or something like that, maybe even a 15-20 amp breaker. Those aren't that smart. Some of the bigger ones, like your battery backup units, those are a lot better and they work very well, especially when you're querying for power status and things like that. I believe the card on it is a little bit bigger, so it has more processing power, especially when you're doing things that you have to watch the battery and get warnings on it as well. Anyways, I can get around this limit by using some type of APC smart PDU unit, and then even having multiple control boards as well. And because the way I'm trying to design the system is pretty modular, I can add control boards like this. I can add control boards. I can add branches. So I can add stems, GrowBox stems, because this is what this is. The stem is the control board, controlling lighting, irrigation, I was going to say water, but irrigation already covers that, and anything else that needs to be connected to these ports. And then this one just has this integrated into it, just because I want to try and have an all-in-one solution for this small prototype that I'm making, which is that wood skeleton that I have in a previous video. So with all of this, I'm trying to make it modular to where I can just add these things as necessary and then expand the whole setup. But pretty much this is it. I do still have to connect or glue on the what's that thing called again? The PoE injector or splitter. But now I can actually have cables coming out of here and everything like that and go from there. Kind of want to take a break for the night. I'll probably start with the glue on that and just get that on there and go from there. But yeah, this is it. Real nice like. Alrighty. As always, thanks for watching. Alright, so can't stop, won't stop. Got the new Raspberry Pi hooked up here. Just ran all the updates for the system and installed the Raspberry Pi Python 3-RPI.gpio installation file there, or daemon, or binary, whatever. This allows you to control the GPIO pins via Python 3, which we won't be using. We'll be most likely doing Node.js here in a little bit. But I know I have this script running and ready to go. So I just did the edits to the file here. Pretty much it's all the pins 29, 31, 32, 33, 35, 36, 37, 38. And just running through setting it up, then output to high, which turns everything off and clears it, or turns it off, and then set the output to low, which turns it on, sleeps for 10 seconds while it's still on, and then shuts everything off and then cleans everything up. So you free up those GPIO pins, and you have to clean everything up just to make sure that it's available. So just gonna run this just like we did before, Python 3, and all later on. Let's do it like this. It's gonna be great. Yeah, there we go. Cool. That's it. So our control board, everything's wired up fine. I guess, after my initial test and everything like that, this works out great. So, hey, I guess it's good to have something work. Alrighty, guys. As always, thanks for watching.